Welcome everyone. Gas volume calculations come up in AQA, OCR and Edexcel A-level chemistry exams. In this video, I'll take you through a specific type of gas volume question that does not require you to use the ideal gas equation PV is equal to nRT. It is vital that you know when it is appropriate to use this method to ensure that you get the correct answer as efficiently as possible. There are more videos on the channel explaining how to approach different types of question involving gas volumes. Check out the links in the description for more videos. Let's get started. Here's the question. 40 centimeters cubed of nitrogen was reacted with 60 centimeters cubed of fluorine according to the equation below. What is the volume of the gas mixture after the reaction at constant temperature and pressure? And we have half a mole of nitrogen reacting with 3/2 moles of fluorine to make 1 mole of nitrogen trifluoride. Before we go through the answer, let's look at some theory. Avogadro's law states that, at constant temperature and pressure, equal amounts of gases contain the same amount of substance, in moles. For example, at a given temperature and pressure, 25 centimeters cubed of nitrogen contains the same amount of substance as 25 centimeters cubed of sulfur dioxide or 25 centimeters cubed of any gas. It is important to remember how amount of substance in moles is related to the number of particles and Avogadro's number. The equation's given there. For a gas, the number of particles usually refers to the number of molecules. If we look back at the question, it states constant temperature and pressure. This is a big clue that we should use Avogadro's law. We are given the initial volumes of nitrogen and fluorine. At the beginning of the reaction, there will be 0 centimeters cubed of the product, nitrogen trifluoride. Next, we have to look at reacting ratios. Half a mole of nitrogen reacts with 1.5 moles of fluorine to form 1 mole of nitrogen trifluoride. It might be clearer if we rewrite the equation with whole number ratios. 1 mole of nitrogen will react with 3 moles of fluorine to make 2 moles of nitrogen trifluoride. So we can see that nitrogen reacts with fluorine in a 1:3 ratio. 40 centimeters cubed of nitrogen would require 120 centimeters cubed of fluorine to react. However, the question tells us that there is only 60 centimeters cubed of fluorine available. This means that fluorine is the limiting factor here and nitrogen is in excess. 60 centimeters cubed of fluorine will react with 20 centimeters cubed of nitrogen. Because the amount of a gas present at constant temperature and pressure is proportional to volume, we can say that 20 centimeters cubed of nitrogen will react with 60 centimeters cubed of fluorine to produce 40 centimeters cubed of nitrogen trifluoride. All of the fluorine reacts, so 0 centimeters cubed of fluorine remains when the reaction is complete. 20 centimeters cubed of nitrogen reacts. The original 40 centimeters cubed of nitrogen is reduced by 20 centimeters cubed, leaving 20 centimeters cubed remaining when the reaction is complete. During the reaction, 40 centimeters cubed of nitrogen trifluoride is produced. The question asks us to give the total volume of the gas mixture at the end of the reaction. To find this, add up the volume of each substance. The total volume of gas at the end of the reaction is 60 centimeters cubed. That is 20 centimeters cubed of nitrogen plus 40 centimeters cubed of nitrogen trifluoride. Here's a similar but different question for you to have a go at. Pause the video and press play when you're ready for the answer. The initial volumes of hydrogen and iodine are 40 centimeters cubed and 60 centimeters cubed. Hydrogen reacts with iodine in a 1:1 reaction here. 40 centimeters cubed of hydrogen will react with 40 centimeters cubed of iodine, meaning that the iodine is in excess. For each mole of hydrogen that reacts, 2 moles of hydrogen iodide are formed. Using Avogadro's law, we can state that if 40 centimeters cubed of hydrogen reacts, then 80 centimeters cubed of hydrogen iodide will form. The final volumes of hydrogen, iodine and hydrogen iodide are 0 centimeters cubed, 20 centimeters cubed and 80 centimeters cubed respectively. The total volume of gas after the reaction in this case will be 100 centimeters cubed. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.